The hydraulic system delivers pressurized fluid to the brakes at each wheel. The main components in the hydraulic system are the master cylinder, brake lines and hoses, balance control system with a metering, proportioning, or combination valve, and the wheel cylinders or calipers. To view the fluid flow through the system, click the tabs. The fluid in the reservoir flows through the master cylinder and exits through two master cylinder ports. The fluid then flows through two independent hydraulic circuits. Each hydraulic circuit consists of lines and hoses. Depending on the vehicle application, the metering, proportioning, or combination valve will regulate fluid flow to the front and rear brakes. The fluid is delivered at the appropriate pressure and timing to the brake calipers, and if the vehicle is equipped with rear drum brakes, to the wheel cylinders. The fluid pressure causes the brake calipers and wheel cylinders to apply, stopping the vehicle. The master cylinder is used to convert mechanical force from the brake pedal and booster into hydraulic force, which moves the pressurized fluid through the brake system to the wheels. A dual master cylinder contains primary and secondary reservoirs, a reservoir cover, primary and secondary pistons, return springs, a pushrod, and ports. Operation of the dual master cylinder can be divided into three broad stages: at rest, applied, and released. Please click on the buttons to learn more about these stages of dual master cylinder operation. When the brakes are at rest, the passage between the reservoir and the hydraulic circuits is open. This allows the brake fluid to expand and contract as needed due to temperature fluctuations. When the brakes are applied, the primary and secondary pistons move forward. The piston seals pass the compensating ports and close the passages between reservoir and the hydraulic circuits. Because the fluid cannot flow back to the reservoir, pressure throughout the hydraulic circuits increases. When the brakes are released, the piston seals pass the compensating ports, also known as bypass or vent ports, and reopen the passages between the hydraulic circuits and the reservoir. The return springs assure the master cylinder pistons and seals retract to the fully released position. The compensating ports allow the brake fluid from the hydraulic circuits to return to the reservoir when the piston seal is in the fully released position. During normal operation, brake linings wear down and brake fluid fills up the space created. This causes the fluid level in the master cylinder reservoir to drop slightly. If the fluid level drops dramatically or needs to be topped off often, there may be a leak in the system. There are several precautions to observe when working with brake fluids. Use only the type of brake fluid recommended by the vehicle manufacturer. Using the wrong fluid may cause brake fluid to boil or component failure, leading to loss of braking. Because DOT3, DOT4, and DOT5.1 brake fluids readily absorb moisture from the air, do not leave the master cylinder cover off any longer than necessary. Remember that DOT3, DOT4, and DOT5.1 can damage paint and wiring if spilled. Exercise caution. Click on the numbered tabs to view the status. Make sure that the reservoir cover is clean, otherwise dirt may enter the system. Next, remove the reservoir cover along with the diaphragm. Ensure that the reservoir cover's vent hole is clear and open. Now, inspect the diaphragm, if present, for damage such as holes or tears, and replace it if required. Check the brake fluid for rust and contaminants. Depending on the type of fluid, it may be clear to light amber. Color, however, may not always indicate the brake fluid's condition. Many automotive service organizations support testing the copper content of brake fluid, although manufacturers may not call for it. Check copper content in fluid by dipping a test strip into the brake fluid reservoir. The copper level should be less than 200 parts per million. Check the fluid level. The fluid should be within 1/4 inch of the reservoir's full line. Add the recommended brake fluid if necessary. Finally, when done, replace the cover of the master cylinder reservoir and diaphragm. Brake line tubing carries brake fluid throughout the hydraulic system. Typically, brake line tubing is made up of copper-fused double-wall steel tubing with a diameter ranging from 1/8 to 3/8 of an inch. It's bonded at an extremely high temperature and has a tin plating to protect it from corrosion. Brake line tubing is connected to junction blocks and other tubing sections with threaded fittings. When installing brake tubing, do not twist it. Twisting may weaken the tubing and lead to brake failure. Fittings are generally made up of steel or brass. There are two kinds of fittings: inverted double flare and iso flare. Click on the buttons to learn about each. The inverted double flare fitting folds back on itself to maintain strength. There's a 45-degree taper inside the flare. The iso flare, also called the bubble flare, does not fold back on itself. Its outer surface forms a leak-free seal against the tubing. There are specific guidelines that you need to follow for installing new brake fittings. Most importantly, when you're installing a new fitting, never change the vehicle's original fitting style. Also, the metal composition of the new fitting should exactly match the tubing to which it's to be joined. Like brake lines, brake hoses are used to deliver hydraulic pressure. Brake hoses provide flexible connections to the wheel. They're typically 10 to 30 inches long and are constructed of layers of fabric impregnated with synthetic rubber. This structure gives hoses the ability to withstand the high temperatures to which they are constantly exposed. The balance control system controls the flow of hydraulic fluid to the front and the rear brakes. It ensures that the front and the rear brakes are applied with appropriate timing and pressure. Depending on the vehicle, a metering valve, proportioning valve, or combination valve may be used. A metering valve is only used with a front disc and rear drum braking system. The metering valve delays the flow of the hydraulic fluid to the front disc brakes, enabling the rear drum brakes to slightly apply first. This component activates either in the initial phase of the braking application or during light braking. In a front-to-rear split hydraulic system, the metering valve may be a separate component or incorporated in the master cylinder. In a diagonally split system, the metering valve may be attached to the master cylinder. Fluid pressure within the hydraulic system affects the function of the metering valve. Click on the buttons to learn more about the operation of the metering valve. When the brakes are at rest and no fluid pressure is applied, the metering valve remains open. When the brakes are applied and the braking action begins, fluid pressure also starts to build. This pressure closes the metering valve's passage to the front brakes, blocking fluid flow to the front brake lines. Pressure is only delivered to the rear brakes. As a result, the rear brakes start applying first. Finally, as fluid pressure increases, the passage to the front brakes also opens, allowing fluid delivery to the front brakes and caliper application. When the brakes are released, the metering valve piston closes, but the valve stem passages remain open. This allows the fluid to escape back to the master cylinder. The proportioning valve limits hydraulic fluid pressure to the rear brakes. This function becomes even more important in case of hard braking when the weight of the vehicle shifts forward, decreasing traction between the rear tires and the road and allowing a greater chance for the rear brakes to lock up. Many vehicles have a standalone proportioning valve. With front-to-rear hydraulic split systems, one valve is used. Two valves are required for diagonally split systems. On some vehicles, the proportioning valve is installed onto the master cylinder. Click the buttons to view the operation of the valve. During most braking, or when the vehicle is in its normal rest condition, the passage to rear wheel circuits remains open. During hard braking, the sudden pressure increase closes the outlet to the rear wheels, preventing premature lockup. Another type of proportioning valve is the height sensing or load sensing proportioning valve. It's normally mounted near the rear suspension in the hydraulic circuit. The height sensing proportioning valve senses the load on the rear axle during braking through the height of the chassis above the axle. It allows more or less braking pressure depending on the load. For example, a heavily loaded truck could allow more brake apply pressure during braking because there's less possibility of its rear brakes locking up. The situation is reversed in the case of a lightly loaded truck, which allows less brake pressure to avoid locking up the rear brakes. The combination valve was developed to simplify the brake system and to save money by building 2 or 3 valve functions in one valve housing. Each valve section functions as it would if it were housed separately. There's a slight disadvantage to the combination valve. If one function fails, the entire unit must be replaced. A two-function valve contains a pressure differential valve, also called a brake warning switch, as well as either a metering valve or a proportioning valve. In a three-function valve, there's a metering valve at one end, while the center section has the pressure differential valve and the other end has the proportioning valve. This component has covered the components and operation of the apply and base brake systems, the operation of the brake warning system, the operation and service procedures for the brake lamp circuit, the components, operation, and basic service procedures for the hydraulic system, the operation of the metering valve, proportioning valve, combination valve, and the dual master cylinder, the features of brake lines and hoses, and the operation of the balance control system.